If your teen is taking chemistry or physics this fall, there's one math-based skill they'll need over and over again, and that's dimensional analysis. It's not only the key to solving many science problems, but it's also where many students get stuck. Today, I'm sharing why this skill matters, how to help your team build it now, and simple steps to make it stick. Welcome to Teaching High School Science. I'm your host, Doc, a former biochemist turned high school science teacher and private tutor. Whether you're homeschooling your teen through high school science or teaching online, join me as I share tips and strategies I've learned over the years for at-home and online labs and activities, breaking down complex concepts and structuring learning in a way that makes sense. Now, let's dive into today's topics. Let's start with the basics. Dimensional analysis is a method of converting units using fractions, and it's used in science to solve problems including converting from grams to moles, switching from seconds to hours, figuring out how many molecules are in a given amount, and a ton more. And it's a skill that is heavily used in both chemistry and physics. The idea for dimensional analysis is simple. You cancel out the units or substance that you don't want, and you replace it with the unit or substance that you do. And you do this using something called a conversion factor. So examples of conversion factors would be 12 eggs equals 1 dozen. This statement can be changed into a fraction where I can cancel out either 12 eggs and change that into a dozen, or I can cancel out 1 dozen and change that into 12 eggs. Another example that's specific to chemistry is 1 mole equals 6.022 times 10 to the 23rd particles. I can convert between moles and particles depending on what my question is asking me to do. Why is this important? Well, it is very important because it helps to keep your students grounded in the meaning behind the numbers. It also helps them to keep track of their units and their substances as they're converting between different numbers and different substances. It takes them from just plugging numbers into a formula, which they may do if they're just trying to memorize the process, to thinking logically about what they're doing and why they're doing it so that they can apply this across multiple situations that will have some slight differences. So now let's talk about where dimensional analysis may show up so that they will be prepared. In high school, chemistry and physics don't necessarily give them a whole lot of time to ease into dimensional analysis. Many chemistry classes, it shows up right away. You may have a little break before it shows up again, but they usually are introduced to it that first month within chemistry. In physics, it shows up immediately and it never goes away. It's always there in some way, shape, form, or fashion. In chemistry, students will be expected to use it to convert from grams to moles, from moles to molecules, to work through various types of stoichiometry problems where they're given one substance or given 2 substances and asked to determine which is the limiting reactant, how much of the product or how much of the reactant is needed in order to form a product or reactant. And in physics, it's used across just about everything. They are going to be using dimensional analysis frequently. So if your team doesn't master this early, it can become harder and harder to keep up. The good news is that it is totally teachable with the right structure and the right type of repetition. There are parts of dimensional analysis that is just repetition and memorization of how to do it, but the application of it changes depending on the various situations. That's where it gets a little tricky. So now let's talk about some practical ways to support your team now as well as when school starts. The first thing is what I call the cancel, replace template. This template is a fraction, and the fraction includes what you want at the top and what you want to cancel out at the bottom. So what you want to convert to will be in the numerator of your conversion factor, and what you want to cancel out will be in the denominator of your conversion factor. So let's use the conversion factor of 12 eggs equal 1 dozen for this example. Let's say you're asked how many dozens equals 84 eggs. So what they would need to know is that because they're given 84 eggs and they want to get rid of eggs and convert that to dozens, the fraction they will set up to cancel will have what they want to get rid of in the denominator, which is eggs, and what they want to convert to in the numerator, which is dozen. Using this template helps to make that thinking visual. It takes that abstract and moves it into concrete. And it also encourages your team to write out the units each and every time. That's important because it helps them to keep track of the units 4 and 5 steps down the line. Another thing is to create a problem notebook. Have your team keep a dedicated page in the notebook for each type of dimensional analysis problem, whether it's grams to moles or liters to particles. This becomes a quick reference that they can turn to all year, especially when they start layering in those multiple conversions in one problem. Next, have them use verbal explanations. So once they solve a problem, have them talk through it out loud. Ask them questions like, which conversion factor did you use? Why did you use it? Which unit were you trying to cancel? And what are you trying to solve for? This forces them to process out loud, which helps uncover any confusions that they may not realize they have, because they're hearing themselves talk through the process not only validates what they already know, but it also allows them to hear areas that they may need to go back and review, as well as alert user areas that they need more reinforcement in. The last tip is to practice in small batches. So instead of giving a worksheet full of 20 problems, which can be a bit overwhelming, start with 2 or 3 a day. One example, one practice, and then maybe challenge them with another one. Focusing on the accuracy over the speed will help them to take the time that they need to become confident in the process. And with confidence will come speed. So the key is repetition, structure, and clear feedback. No matter if you're homeschooling or looking for support with your team through their science classes, this tip will help them in both chemistry and physics. If you want more structured support in preparing your team for their high school chemistry or physics class in the fall, I've linked my physics summer camp and my chemistry summer camp in the show notes, which is a live summer camp offered throughout school. Just click on the link and find out more about each option and the times that they are offered. And also, if you're just looking for a bit more math support, then check out my Math Essentials mini-series, which is also linked in the show notes. Let me know if you have any questions, ideas, or other experiences that you'd like to share. Head on over to my podcast page, which you can access by visiting my website at thesciencementor.com. Then select podcast from the menu and subscribe now to the Teaching High School Science podcast for your regular dose of motivation and just-in-time science ideas. And together, let's make high school science a journey of exploration and achievement. Until next time, remember, curiosity leads to endless possibilities.